Hello everyone, welcoming you all to the session 2. So here we are going to do the example number 3, and here you will find example number 4 which needs to be done by you, right? So the example number 5 is a bit of complicated, so we'll be dealing this in the third session, actually the third lab, right? So it is quite similar to the gear pump, so we'll do it there, but we'll be drafting the SolidWorks file or the part file. We'll be doing in this session, right? So we'll start with example number 3. So as you can see, this part is quite can be simply done, right? So it's not a complex part. So we'll start with the part file, right? So as I said in the previous session, make sure to draw this in the simplest way that you can. So the dimensions are 130, right? 130 and 90. So center rectangle. Dimensions 130. Make sure always check the units, right? So here it is, millimeters, as well as this side it's 90. Okay, that's done. So we'll find the thickness of it. It's 20, right? So we should extrude it to 20. That part is done. So we'll have to have a reference plane now in order to proceed with the next features. So coincidence. Okay. And then here the dimensions are not given, but we'll go with 10 millimeter deductions from the length and from the width, right? So the sketch, so it will be 120 and 80, right? So even the fillet is not given, right? The fillet radius is not given, so we'll take it as 15 as in the previous examples, right? So fillet, keep it to 15. Okay, and then we have to extrude it as well, right? So in extruding it should be 2 millimeters, right? So this entire part here is having a thickness of 2 millimeter, and the top part is having a additional 3 millimeter, which adds up to a 5 millimeter, right? So make sure in every drawing that you do to recheck twice, right? So the dimensions could mislead you. So this is done. Extruding to 2 millimeter, right? So that's done. So then another reference plane, right, since it's another feature that is on top of the second feature, right? So we'll have it here. So as you can see, they have given the dimensions for it. So it is center circle first at radius 20, and then this part is a 16 rectangle, right? So we'll sketch this, a radius of 20, right, which is 20. Okay, and then a rectangle of 16, right? So this area, this length should be 16, right? So it's a matter of trimming, right? Right, so this is okay, but there is another thing that needs to be concerned. There is a small fillet going on from here with a radius R10, right? Fillet, okay, so this is okay, and as you can see, it is a 3 millimeter, right? A 3 millimeter height of extrusion, right? So it's 3 millimeter. So now the part is done, right? As you can see, this is the part that is given in sketches here, right? So in this example, the outside profile may need to be completed in two parts, as using G2 and R may not give the correct profile, right? So the outside profile here, the outside profile in the sense, you can see here there's two outside profiles, right? So this is one part, the inner part, right? And there is another profile coming on to this, the border, right? This border is another part, right? This part is another profiling, right? So we'll go on to this. So make sure you save this, right? So there are no fixtures, no operations. You can start with the face milling, right? So if you have gone through the first video, you know why face milling is done, right? So the face milling is okay, right? The same coordinating system. You have to select the tool, right? Create the new tool, and it is a face mill. Since they haven't given any tool selections, we can go with our on, right? So I would prefer having the diameter 40 as a face mill. That is a standard tool, right? And the levels, of course, you can, it is already defined, but you can user define it again. Upper level, which is the 0th coordinate, right? 0 point, and the face depth is this, right? So that is the part that is facing, having the highest point actually, right? So having that, you can go to equal step down, which means that the face mill will go on a equal level distance, right? Step down. So we'll select with the hatching technology, which means the hatching path, right? The machining. So the flow finish, of course, we can give it here, and so there are more features to be given, but we'll go on with this first and see how is the machining done, right? Right, so that's not an issue. So to show the rest material, so we can see it has already done the machining here. So in the rest material we can see now the part can be seen, so that the phasing has been done properly, right? But there's a small thing that needs to be done, right? As you can see, there's a small part left, right? So to cut that rest material, we can include a rest material option, or else we can straight away do the edit the machining again, right? So here, of course, you can go to this at the cross. So the not the along in the sense that this will be moving this part, right? So the cross diameter, the cross distance actually can be changed, right? As you can see at the below left corner, right? So the tool diameter will have it as 10, right? Calculate this and then have this here. Right, so now there is no remainder here. The rest material, of course, you can see now it's done, right? So the first part is okay, this is fine, and then next another operation, which is the first profile, right? So since this is a new operation, we need to assign the coordinates and the cutting path, right? So we have to select this. So please do not select it like this, right? Do not select it like this, and this will cut, but there will be remainders at these corners, right? At these corners, acute corners, right, or 90-degree corners, there will be some remainder. So we are not going to do that. So we'll be machining this part, right? So you can select the direction of the cut, so that is why you can change the direction here, right? First accept, do not accept it, and then change the direction. If you accept it as okay, you cannot change any, right? So you can set up the direction. So as I said before, clockwise operation, right? It is going in clockwise, so now it's okay, yes, right? So that is fine. The part that needs to be cut is selected, and we can give the depth, right? So selecting this as wall, what is the radius? It's 10 here, right? So it will be machining in this way, here, and this, starting from this point. So we have to assign this point first as the corner position or the offset, right? So we'll assign a new end mill, right? An end mill with say since this is Yes, the radius here is 10. We can go with the 20th tool, or else we'll anyways go with the middle in between 10 and 20, right? So we'll go with 15. Okay, so here you can assign the size, right? The depth is this, right? And going on to the technology, you can see the geometry, how the machine or the tool will be moving, right? So it will be moving out from the out of the feature, so that there is no harm done to the feature, right? So it is okay. Depth, you can use it as constant or helical, right? We'll go with the constant here, and first of all it should be rough. So the first pass will be a rough, and then it will be finishing. Actually, when we are machining, of course, we'll be machining, the initial machining would actually give out a rough surface, or not a fine surface, right? So in the second pass only we'll be doing the, or the second step only we'll be doing the polishing part or the finishing, right? So we'll take the rough and the finish as well, right? So we can use equal step down, right? That is an option, right? So the rest material, this is not the rest material part, this is the original part that is cut, right? So we'll go with this, and the ramping, right? As I said in the first video explained, it is explained. Now we'll go with the same as feeding, right? And then the lead in and lead out, you can have the same, right? So these are okay. To the machining, so this is the part that was cut, because we haven't given the offsetting value, right? So now we are going to give the offsetting value here. Clear offset, click the offset, and then you can give the coordinating part, right? The coordinates. So the step over, you can have the step over around we'll try 10, right? And the final pass, right? So solid rest material, now you can see the first two features are done, right? So this is okay, right? We'll accept that, and then of course we have to have another profile cutting here, which is this part, right? This area. So same as that, we can have another profiling, right? So since the levels are different, and actually you can copy paste and give different levels as well, right? Anyways, we'll be going with a new geometry here, right? So first of all, just see where the part is moving. Yes, it is pointing towards path of clockwise, right? So it is okay. Yes, all right. Then the tool, here we can go with the same tool, right? So the machining would be not that expensive, right? If you have a bunch of various tools, it would the machining would actually cost, because like you have to use for each and every machine operation you have to use a different tool. So having the same tool, of course, would reduce the machining setting time as well as cost, right? So time is cost actually here. So the technology here, right? So the geometry, you can see it is moving out of the feature, right? Okay, this is okay. Rough equals step down, constant will use as helical. Now it will be going in a helical path, right? And this is okay, right? So same as this also we can use as helical here. Oh, sorry. So here you can see there's a small error that we have done. You can just use ramping as rapid or feed, because the helical here is mostly used for like boring, right? It will be cutting at one place and then moving on to the others, right? So it would be taking much time, right? So here you can use this, and then right. So now it is done, but there is a small remainder rest material at the corner, right? So here you can go to the technology, and then so we can always here of course we can have, this was 0.5, right? So now we can have 1 or either 1.5 as the wall offset, right? So that it will move, right, a bit. It will offset a bit of given specification, and then start the machining, right? So with this we can try and see how the calculate this and then simulate. We can see right. So there was a offset, small offset, right? So you can see a small offset here, right? So now there is no remainder at the edges, right? So here by rest material you can verify there is no any remainder at the corner, right? So this is done, and then machining, and then what is the next part? This is, forget here this part, the outer boundary. So that is also a profile, right? So are we going to cut it directly to this point? No, because at the end we will be anyways fixing this to a machine wise, right? So if we are going to machine this, it would interrupt the machine wise, right? And the process would be false, right? So in order to prevent that, we'll first of all machine halfway down, right? Having a small, we have around to get from this part, like from the below, we normally fix to the vise gap, with a gap having a clearance of 10 millimeter, right? So from here you can see whether there is, right, for this point there is 16, right? So it would be right, you can have around this place, right? So we'll see from here to here it was 6, right? So we can have it around this place, right, leaving space for the machine mounting, right? So we'll go to milling operation, and then here is another profile, right? So the same tool can be used, but here the coordinating system is again right. We'll see whether it is in the correct position. And it is moving in the other way, so we can shift from here the directions, and this is okay to go, right? Then go to the tool and select the same tool that was done, right? And the levels you can use it, define it again, right? Anyways, you have to use a define because it will cut throughout if you haven't given the correct depths, right? So the starting depth is this, and the profile depth is say profile depth around here, right? So this point it was 16, right, from below. So here, okay, this is allowable, right? So the geometry you can see if you want to check, right, it moves out of the feature, right? So then the rough part, pass equals step down, right? You can use helical here again. So it means that it cut down as a helical motion. We'll see, right? So we can simulate this. Right, it is going down as a helical path, right? Now you can see from the rest material it is machined to the expected levels, right? So now this operation is done, right? Now of course we have to rotate this part in order to machine it from bottom to top, right? So this is the bottom surface, right, bottom to top. We have to align this, rotate this part, and machine again from a new coordinating system, right? So operations and milling. Now first of all we have to do the facing, right? So here the coordinating system, you have to go to the coordinating system, right? That is by this, and then add a new coordinate, right? Select the part first, then it automatically selects, right? So pick origin and this, so this is the height, right, of the stock. You can flip this around Z, right, so that it aligns according to our requirements, right? right? So this is all set. Okay, and here face milling, right? So define, right? When you select define, it automatically selects it, right? So this is okay. And then the tool, you can select the previous facing tool here, right? Levels, you say define it to from this place, right? So it's 0 to the face depth. Okay, so you can use the equal step down. We'll have a equal step down here. Hatching motion, contour, go with the contour. Alright, finish. Right, we'll calculate and see whether this works. Right, so that was the final pass. From the rest material we can see this is okay. Yes, this is acceptable. Right, so that is done. You can have another operation for the final profiling, that is out of the boundary here. Now this is mounted from the below, right? So I won't accept it because the direction is anti-clockwise. Here we can select it to the correct way that we need, right? So here it should be again the position tool, right? Tool, similar, second tool here, used in the previous profiling. Levels, upper level can be given here, and the lower level, profile depth. We can use this posture, right? Right, so I just need to generate the G code here. Okay, so we'll calculate all again, right? So you can see these operations here, right? We'll just do a small overall, right, the overall simulation here, and see how it, right? So solid verify from the block, of course we can see. Okay, okay, so then the bottom machining, right? So it will be mounted in the other way. Okay, so this is done. So the simulation is fine. Now it is a matter of generating the G code for all, right? So generate. Okay, so you can save this. And example number 5 will draw this as a new part file now, right? So it is looks complicated, but when you're actually drawing it, you can use the simplest methods, so that it is not that complex, as you can see, right? So we can save this, right? So in this part we can say this is machined from a cylinder, right? So what are the components that are visible, right? So we can see a slot here, right? 4 drills here, and in the middle drilling, and a pocket in the middle, right? So this is, now in sketching this, of course we have to have rectangle guide construction guides, right? So let's start, right? Okay. So the starting with the entire circle, right? If you think this as a circle, this would be 40, right? R40. Okay, and then you can see that we can have a rectangle of 30-30, right, through the center, dimension here, you can check this as 60, right? And then you can start trimming here, right? So okay, so this is ready to, yes, this part is now ready to extrude. So the size is 20, right? So having that, then next we can start the pocket area, right? So the pocket area is somewhat new shape, right? So how can we draw that? Okay, so we know there are two circles, right? R16 is the radius of this, right? So coincidence, right? Okay, you can go to this. Before that, right, as a construction, now the centers, the distance of the centers are 14, which is 28, right? So the 28, we can draw a small construction line for that. Okay, so yes, midpoint line would do. The midpoint line from here, so we can give the dimensions is 28, right? Okay, and then draw this area. Just give me a second. Here, oh, rather than that, that's having two circles here would be easy, right? So we'll go with two circles of R16. Okay, so equal these two, and then okay, and then so that is fine. Now there is a small okay, we can create a rectangle here, right, from the midpoint. So it is 28 again, and there is one more thing to consider. So the distance of this, right? Okay, we'll move on with this for the moment, right? Okay, and then start trimming this. So okay, so seems okay, so you can see the dimensions are okay, right? Now this is a extrude cut, right? Extrude cut of 15. So we'll cut this and see. Looks good, right? And then the next right, so then we can drill this, right? There's a small drills at the middle of the pocket which goes through, right? So which is we'll sketch on this itself, right? The same plane, right? Since it is going through, there is no point of having a new yeah. We can make this visible so that it would be a guide for us, right, to get these 2 points. So here you can see it is R4 first and then R3, 2 circles, right? R4, R3, okay. Extrude cut trick, right, through all. Okay, so that is also done, right? So the pocket area is cleared. Now we have 4 drill holes left and the slot of 3 millimeter, right? So first of all we'll go to the yeah, we'll do the slot process here, right? So we have given R20. So from center line of the groove to this point, right, to this center and the center line, it's R20, right? So we can have the same plane here, right? So editing the same plane. Now we can get a straight slot here. So this is the center line that went here, so it is 20, right? R20. Okay, and you have to do a small mathematic here. So the center line will be right at the middle of this, so 1.5 up and down, right? .5. And another one. .5, right? So we see that there is a small error here, right, compared to the diagram here, right? So seems like the slot here is big than the outer radius. I will check the outer radius first. I think it has gone out of the dimensions, right? So we'll smart check this. It seems like it's 35 and it's not 40, right? So we can adjust this again, go back to the first sketch, right here, and then give this as 40, right? So seems okay now, right? Pretty good. Okay, now we can move to the cutting, right? So there's a slot of 3 millimeter with a depth of 2 millimeter, right? It's a groove. So the sketching is done, okay, right? Can go to extrude cut this. Alright, before that, right? You can delete that first sent line, right? Okay, with the sketching on, right, editing on, you can go to extrude cut here, and it is okay, and it's 2 millimeter in depth, right? So that is also done here, right? In the same plane, we can go for the drilling here, right? So there are 4 holes, M5 into 0.8, 15, right, length full thread, right, 15 millimeter. Which goes by 25, 24, 24, which is 48 here, and this way again 48, right? So we'll give the edit this, right, edit sketching, and then have a box of which is 28, 24, 24, 48, right, 48, right? So this is none. We can have the, we can go to it says to save the document. Please make sure you save it, right? This will save it in lab 3, right? So we are doing it in lab 3. It's part 5. So the whole wizard, right? So here we can go to whole wizard, right? And then it's a straight tap, and then it should be the standard of ANSI and C metric, right? It should be bottom tapping holes, right? So the size was given as M5 into 0.8, M5 into 0.8, right? So whether it is through all, this full thread, right? So they have given the length, right? So it is going to a depth of 15 millimeter length, right? The full thread, okay? It's a full thread. So here the blind size, you can, the depth you can give as 15 millimeter, and the thread when condition is 15 and the thread is as well 15, right? It has said in the full length of, full thread length of 15, okay? So we'll give this and save. just come up to this. So that is fine. Now the 4 holes, right, are done. Let's move additional 2 holes here, right, 2 holes, 15 deep. So here, to have the sketch, you can have a rectangle of this here, right? So having that, it will be 48 and 28 from the center. Okay, so we can start sketching this again. .48 and 28, right? So it's fine. It's 3 millimeter diameter, 15 depth, so that is fine. Go back to hole wizard here. Alright, just a hole here, 3, 15. Positions, there's one here and another one here, right? So that's also done. So the part is quite right, the sketches, we can hide them. So this is the part actually which is shown from here, right? There is no much big deal about it, right? Okay, it is simple if you follow the simple steps, right? So this, there's a small thread, there's another thread going here, right? But it's not, the dimensions aren't given in this in drawing, right? So I will edit the part according to that, and there is no 2 holes here and here, right? So alignment holes, right? We'll do this machining part, right? So this the threading, I will not be doing that, right? It is not that hard, it is simple, right? Just getting a reference plane here, right, to the sideways, and then through all drilling with the thread, right? So that is easy, and we'll do the machining part in the lab 3. Okay, so for the moment, just try, make sure you practice this, right? Okay, example 3, example 4, and start drawing the example 5 as well, right? So the machining can be done for the example 4 and example 3 by you, so make sure you practice this, right? So alright, thank you for watching, and join with the second lab. Okay, thank you.